look at example 1. There's 2 words that are screaming out to me that are the key to this question. Can you see the 2 words? Constant speed. I would underline those. What does constant speed mean in terms of winner and minus loser and forces? What can I conclude? Anyone? More specific than that. What? Allie, loud and proud. Thank you. I would actually go. This might be so complicated, there may be more than one, there may be like 3 or 4 forces. So to say they're equal, here's what I do know. It's going to be winner minus loser equals 0. If there's only 2 forces, I might be able to see the tug of war. I don't know because I haven't done my free body diagram yet, but I may need more than that. Okay. How much force is required to pull this mass up the frictionless ramp? Oh, no friction at a constant speed. Oh, I was going to say, hope I did a friction example. I did. So constant speed. Any suggestions on how I might want to start out? And I'm technically not doing a proper free body diagram. I find it much handier to label the ramp itself. Technically, I should be doing it off over here. Forget it. Let's go to the block. What are the forces acting on it? Get the obvious one. Pause, because there's a ramp. I'm going to put the mg on the same side as the pointy part of the triangle. And I'm going to break this up into mg perpendicular and mg parallel. Color, 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 color. And my 90-degree right angle is there. mg will be the hypotenuse of your triangle if you've done it right. Okay, pause, keep going. What else? Normal force, how big? Not mg, same size as mg perpendicular. And try and draw it so that it's a right angle. Some bad habits, Aiden, I see kids do this sometimes. No, it's perpendicular to the surface. And be a little careful. I see kids, sometimes they do kind of that or whatever. This is why one time you want to be a little cautious in your drawings and try and get the angles right. I can't remember if it was you I made fun of the other. Someone had a really wonky arrow the other day. Was it you? No? Okay, somebody else. It was you. Yeah. Okay. What else? Is there friction? No? Okay. What else? Yeah, is a rope. Yeah, what you were feeling right now. Yes, tension. Yep. Anything else? I don't think so. I think we got it all. Okay. What's the tug of war between in this question? Can you see which 2 forces are having the tug of war here? Tension and mg parallel. And I like what Ali said for this. He said, well, they're equal. Since A is 0, I think we could probably, if we were clever, say mg parallel is the same as friction. No, friction, tension. What's this question asking me to find? When it says how much force is required to pull it, there's no F applied in my diagram. That's a bad guess. I'm sorry, but that's a bad guess. How much force is required to pull this mass up the frictionless ramp? Which force is doing that in my diagram? It's asking me to find tension. I can't, but you know what I can find? mg parallel, which conveniently is the same size as tension. Got the argument? mg parallel, 2 lines. Sine? Tension is going to be mg sine theta. What was m7? G 9.8 sine 40. You'll notice the M doesn't cancel here because there's no mass and tension. It shouldn't cancel because a heavier mass, I would think the rope has to pull harder to lift something heavier up a hill. Yeah, that makes sense to me. What do you get? $44.1. Anybody else? Yeah. Units? Okay. B. Now we're going to add friction. Okay. I'm just going to use the same free body diagram. I'm just going to add friction in. Which way do you think friction would be acting in this question? That way? Sorry? Because which way are we sliding? Up the ramp. So which way is friction? So I'll add it right there. By the way, what if we were sliding down the ramp? Which way would friction be pointing? Okay, we can handle it. You'd get a different tension. But it could be it could be that instead of pulling this up the ramp, it could be that we're lowering it down the ramp. Okay. Here, this is a bit more complicated. Allie, I don't know if I'd necessarily say they're equal, although I think I can see it's going to be a tug of war between tension and mg parallel and friction, and so you might see that. I might say, I'll pick a winner. We're moving up the ramp, even though we're not accelerating. I'll let up the ramp be the winner, and I would have this. Tension minus mg parallel minus friction equals, what does winner minus loser always equal? MA. But what's A if we're at a constant speed? If it wasn't a constant speed, could we still handle this? Yeah. But for now, 0. And now I realize Allie was correct there. Yeah.
Why is it minus friction?
Because I decided to let up the ramp be winner. Which way is friction pointing? Loser! I meant the force, not you. Or did I? Is that okay?
Yeah.
By the way, and again, if we were sliding down the ramp and I let up the ramp be the winner, friction would be a winner. By the way, winner and loser, it's really arbitrary. You could call those both winners and that a loser. In any question, you'll still get the same answers as long as you're consistent. But I think it's easier to think, which way are we accelerating? Let's let that be positive. You have less minuses to deal with and less negatives kicking around. Speaking of, oh, Josh, what did you say they want me to find? What did you say in the previous part they wanted me to find? Thank you for remembering that all of 2 minutes ago. So what do they want me to find? How would I get the T by itself? I think I would plus both of these over. And there's a 0 there, which is really nice. I think I'll get, oh yeah, tension is friction plus mg parallel. Karn? I don't know the normal force. Oh, but look. I know another force the same size as the normal force, but it's not mg. What is it in your free body diagram this time? It's on your sheet of paper. You'll have to look at your sheet of paper. Sorry? Mg perpendicular plus mg parallel. Tension is going to be mg perpendicular. Which trig function was that? Of course it was. So it's going to be mu mg cos theta plus mg sine theta. 2 lines. Do the m's cancel here? Not an m in tension, so no. All right, now it's plug and chug. T is going to be 0.65 times 7 times 9.8. Was theta 40? Plus 7 times 9.8. Sine 40. Okay. Common mistakes, see if you can spot it. So that's a really common one. Can you see what I subconsciously slipped up on my calculator? What? The second G. It's amazing how often kids forget to type it on their calculator because your brain in its mental checklist has already said, yeah, I entered a G in my calculator. So just be really, really meticulous. Before you hit equals, I always get in the habit of scrolling back and forth and comparing it to what I wrote. Do you get 85.45 to 85.5? Or am I wrong? Yep, I'm wrong. Because I forgot to put a times sign between the 7 and the 9.8. Mr. Dewick, you just told us to look carefully, and I didn't do that. 78.3? Yeah, that's better. So adding intention, did that make the question tougher? Longer. I have a hard time saying tougher. Longer. A little more meticulous. We could also combine the Atwood machine and a ramp, like example 2. Okay. This is around as long as I can ask you. The only way I can get longer than this is to have, well, I think I gave you one in the homework. Something like this where there's 2 different ramps with 2 different angles, but I'm telling you, 2 lines is still going to be sine. It's just over here, it'll be sine 30, and over here, it'll be sine 50. Okay. Oh, and perpendicular is, of course it is. Just over here, it's going to be cos 30, and over here, it's going to be cos 50. And just be really, really careful as you're writing stuff out. Make sure you label everything M1 and M2, theta 1, theta 2 to go with mass 1 and mass 2. And as long as you do that, you should be okay. I can throw a lot at you. Meanwhile, let's do our question here. 2 objects are connected as shown. M1 is 12 kilograms. It sits on a horizontal surface, and there's some friction. M2 is 9.8 kilograms and sits on a frictionless surface at an angle of 42 degrees. Find the acceleration. Here's the first thing. Is there any way, if you look at this picture, is there any way that it can accelerate that way? Like, there's no way, if that's a crate, and that's another crate, there's no way a crate would spontaneously start lifting up this crate and crawling on its own. So if we're going to accelerate, which way? Right and down. Or maybe we're not going anywhere. Friction right here could be so big that this is stable. I'll know that if when I find A, I get a negative answer. I picked the wrong winner. Okay. Was that a question? Except I said this surface is frictionless. I'm just making up a question just for giggles. I could add friction. It would just make the question longer. Okay. Often what you'll see is because they realize, look, if you can handle 1 friction, you can handle 2 frictions. They'll often put one of these on wheels to sort of indicate to you, no friction. You'll see that in the ultimate review when you work through. It's a good question. How am I going to start? You already did. Thank you. That's a nice dollop right there. Mm-hmm. So you know what? It's more dab. It's because it's not a little picture. Just saying. Okay. Anyone, what am I going to do? Free body diagram. It wants me to find the acceleration. Follow up. I could also find the tension if I needed to. Did I ask that later? I did. Good. That would have been a great question to ask. So I should have put a little part A right here. What are the forces acting on M1? Get the obvious one. M1G. What else? Same size as M1G. I'll call it normal force number 1 to go with mass number 1. What else? Which way? Yep. And current, I'll call it friction force number 1 to go with mass number. to go with mass number 1. What else? Yeah, there's a rope. Do you see why I meant when I started this lesson? Do you see what I meant when I said, I hope you don't learn anything really new today? I hope none of this is new. Have we dealt with ropes before, Aiden, and tension? Yep. I'm just making more complicated diagrams is all. I think that's everything. What are the forces acting on M2? Get the obvious one. I'll put the M2G on the pointy side. I'll pause. It's a ramp components. M2G perpendicular. M2G parallel. 90 goes there. Color, 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 color. Color, 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 color. What else? I would get to that, but I would probably go systematically. What do I usually do after gravity? I usually say, is it sinking into the ramp like quicksand? Is it flying off the ramp like Superman? Going to be a normal force the same size as mg perpendicular, m2g perpendicular, and I'd call that normal force number 2 to distinguish it from normal force number 1. And now I totally agree with you. Tension. And if there was friction, it'd be pointing up the ramp. Friction force number 2. If anyone's winning, who's winning? Can you see what's causing this whole chain reaction? M what G parallel? M2G parallel. What's causing this whole thing is that if that's strong enough to overcome everything, this will slide down. If it's not strong enough, we'll find out because we'll get a negative acceleration and we'll say, ha, wrong winner. So what we're going to have then, anything that ends up pointing down and right when it gets over there is going to be winner plus. Anything that ends up pointing left will be loser minus. And again, we're walking along the rope. So M2G parallel minus T plus T minus friction force number 1 Notice M1G doesn't make an appearance because it's not along the rope. Equals M all A. Yes. One more day till Christmas break. Oh, I can feel the tension just vanishing. What did this question want me to find? Yeah. By the way, I like this question. This is about what I would call a B plus A minus. This is the kind of question you will see on a test. It's got good teeth. There's nothing technically new, but it really tests, have you wrapped your brain around free body diagrams and Newton's laws? So to get the A by itself, what can I write instead of M2G parallel? M what? Okay. By the way, you think I'm making a joke? The number of times that I've seen kids get sloppy with their notation and put the wrong mass in would astonish you. So get in the habit of calling them what they're called. Just that little subconscious reinforcement, I think, cuts down on dumb mistakes, right? So M2G sine theta minus O'Carn. I don't know the normal force. Oh, but look. I don't know the force, same size as the normal force. Which one? Please don't say mg. Which one? M1G. Yeah, you know what? He is technically right in that the normal force is M1G perpendicular. Perpendicular is which trig function? What is the cosine of 90? Because that's a 90-degree angle. What is cos of 90? It's 1. That cos has technically always been hidden there because we've always been doing a 90-degree angle. So you raised a good point. The perpendicular is redundant in this case, but technically not wrong. Mu M1G. Cosine of 90? Sorry, you're right. What I should have said is this angle here of this hill is a 0 degree angle, and so cosine of 0 is 1, not cos of 90, okay? So when we've been on a flat hill, that's always been there. We just ignored it. Hey, that's not bad. In fact, I can even shorten my little line that I drew. I didn't have to put as much in there as I thought. Have we done our trig? Yeah. Have we done our substitutions? Wait, plug and chug. M2, 9.8 times 9.8. Sine 42 minus 0.17 times 12 times 9.8 all over 12 plus 9.8. Every one of you should type this in, because the number of times I've seen kids have the right equation and the wrong answer on the test drives me crazy. And Josh, that just means they were too lazy to try typing this in. Oh, I guess the built-in error check, A's got to be less than 9.8 because mass 2 is sliding down a hill, but it's not in free fall. So if you got an answer bigger than 9.8, you've made a mistake. Bracket 9.8. You know what? What's a quicker way to type 9.8 times 9.8? I'm lazy. It's just a fluke that those happen to be the same number. Minus 0.17 times 12 times 9.8. Close off the top, divided by 12 plus 9.8. 9.8 times 9.8 sine 42 minus 0.17 times 12. Do you get 2.0307, 2.03? Meters per second squared. Cool. B says find the tension. Remember, to find an individual force, I'll look at an individual mass. I always try and pick the mass that looks easiest or the cleanest. These both look kind of ugly, so I'm stuck with having to do some work. Nick, which mass do you want to use to find tension? Mass 1 or mass 2? I don't care. Mass 1? So what would the equation for mass 1 be? Tension minus friction force number 1 equals M1A. Yeah. Tension minus friction force number 1 equals M1A. Do I need to do swappy dance? No, I'll just plus the friction over. Tension equals M1A plus friction force number 1. If you want to rewrite this, you can, but I would probably on this line do something like Karn. I might cross out friction force number 1 and say mu times you know what? I wouldn't write normal force number 1. What would I write instead? Oh, but look. M1G, right? If you wanted to rewrite the whole thing, you can. On a test, I would probably rewrite the whole thing. My homework, I'll show my work, but be lazy and organized. Because I think now I can go to numbers. I've scrolled down. What was M1? 12. I'm going to write 2.03, but by now I hope you all know I'm going to use my answer button. Minus, what was mu? 0.17 times 12 times 9.8. 12 times answer button minus 0.12 times 12. If you get a syntax error, usually if you go left arrow or right arrow, it'll put the cursor right where the error was, and you can figure out. Yeah, okay. So in other words, when you get a syntax error, don't hit clear. Try going left arrow or right arrow. It'll often put your cursor where your typo was. You get 4.4? I put a minus in between. It's plus. So I wrecked that totally. Okay, I got to get that 2.03 back on my calculator. So there it was. And then it's going to be I wrote a minus as well for some dumb reason. How about 44.36?
Yes.
Yeah. That better? Someone called my name. Yeah? Okay, don't clear your calculator. You did the same thing as me when I subtracted because I wasn't reading carefully. Yeah, and there is so much room to make silly mistakes here too. I've already made a couple. Okay. By the way, could I have given you the tension and said, or sorry, first of all, could I have given you the acceleration and said find the coefficient of friction, the mu? Yeah, you would just get the mu by itself on this line. So you would get friction by itself first of all. And then what did we say? How do you get a mu by itself? Divide by the normal force. Whatever it happens to be. In this case, M1G could be a perpendicular, whatever. Totally fair game. As far as I'm concerned in this equation, I can give you anything but one thing and you can get whatever you need to by itself. Is that okay, Will? One of the reasons I did the 4-minute manipulation shtick with you already last year's, I knew this was coming down the pipe this way. I don't have to teach every specific example. I'll show you the general method and then I'll say, figure it out. It's also way less memorization for you. Example 2. How would you figure out which way this will accelerate? Okay. Now, there are some parts that are obvious. Don't write this down. If this was 99 kilograms and this is 1 kilogram, which way is it going to accelerate? Okay. What about if this was 9 kilograms and this is 10 kilograms? Well, if this is 100 kilograms, I'm pretty sure that'll slide down and lift that 9 up. But these are really close together. This is bigger, but it's on a hill. This has gravity pulling it straight down. This has a component. How would I figure that out? You know what this is a good job for? What are the forces acting on little m? Get the obvious one. Little mg. What else? Normal force? Nope. What are the forces acting on big M? Get the obvious one. Big mg. Components. Big mg perpendicular. Big mg parallel. Color, color, color. Color, color, color. What else? And one more. Oh, yeah. Sorry? Tension. Can you see which two forces are really having the tug of war here? Slide along the rope with your eyes and see if you can figure out which two forces are really having the opposite. Tensions cancel. The tug of war is between those two. And so if you want to figure out who the winner is, what you can do really quickly on your calculator is just crunch mg, remember it, and then crunch mg parallel, mg two lines, sine. And whichever one is bigger, that's the winner. And if you make a mistake, you'll still know it because you'll get a negative acceleration. So let's do one with numbers. Oh, sorry, in our notes here, compare little mg with mg parallel. Compare and if there was two ramps, you would just compare both parallel components against each other. That's the tug of war, because tension is canceling, okay? Then, once you've done that, once you know which way... See, the other thing is, what if there was friction? If it's sliding up the ramp, friction is pointing down the ramp. If it's sliding down the ramp, friction is pointing... I'd actually have to do that comparison before I could put friction in. So I wouldn't know which way to point it. So I like example 3, I like example 3. Example 3 is a great question. Ooh, I even see there's a tiny bit of friction. That's a really small mu, 0.05, but there is some friction. Wants to find the acceleration. Thankfully, they've already dolloped for me. So how will I start? Good free body diagram. I'm going to zoom in a little bit because Marcus is really squinting back there. Marcus, what are the forces acting on this 5 kilogram mass? Get the obvious one. Yeah. And since there's more than one mass, I'll call it M1G. What else? Anything else on that one? Okay. On the 8. Stop, components, M2G perpendicular, M2G parallel. There's the 90, color, 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 color. Same size as perpendicular, I'll eyeball it. I'll call it normal force number 2 to go with mass number, yeah. What else? Tension, this way. And friction, but I don't know which way to put friction because I don't know whether the 8 is sliding up or sliding down. It's bigger. Maybe that's enough to lift this up because it's almost twice as big. But that's a pretty shallow angle. I don't know. What are we going to compare? Quickly get your calculators out, folks. What's the tug of war between here, Carter? Let's do M1G first, 5 times 9.8. Oh, I can remember 49. And now I'll quickly go 8 times 9.8 times 2 lines is 39. Oh, which way is that 8 sliding? Up the ramp or down the ramp? Up the ramp. Which way is friction pointing then? And Marcus, I'll call it friction force number 2 to go with mass number 2. Okay. That's pretty quick. If it's a really, really complicated question, like if there's a whole bunch of things more, like if there's 3 masses or 4 masses, and I can't tell, then honestly what I'll do is I'll guess. Do you know how I'll know I guessed right? If the acceleration when I solve for it is positive. Do you know how I'll know I guessed wrong? But it's a really easy fix. I just flip my friction arrows in the opposite direction. And then in my equation, anything that was a winner, I make it a, I put a minus sign in front of it. Anything that was a loser, I make it a, put a plus sign in front of it. And half the time I can actually just backspace and edit on my calculator and just make a few tweaks and go. So, whatever. Let's solve this. Find the acceleration. Did I also ask you to find the tension as a follow-up on this one or not? I did. Okay. Who's winning? We calculated it. So anything that ends up pointing down and left once it gets over here, winner plus. Walk along the rope. Winner minus loser plus winner minus loser. Can you see which force might be easy to forget because it's not on the rope, but it's still parallel to the rope? Yeah, a lot of kids forget the minus M2G parallel. That's definitely in the same direction as the rope. What's that going to equal? Yeah. If you were really lazy, what are they asking me to find? You could have already on this line just gone, you know what? Or written M all down there. I'll sometimes do that because MA. Tensions cancel. I'll do this the way I would on a test. I'm not going to take any shortcuts. I'm going to be very meticulous because it's way too easy to make a mistake. So I'm going to rewrite this, but I'll bring in all the trig and all the normal forces and stuff like that. So M1G minus, Karn? I don't know the normal force. Oh, but look. I don't know the force the same size as the normal force. By the way, it'd be mu times normal force number 2, which is going to be m2g perpendicular, and then minus m2g parallel, all over m1 plus m2. I got room? Going to be close. m1g minus mu m2g. What will I write instead of perpendicular? Yeah, of course I will. Minus m2g. What will I write instead of parallel? All over m1 plus m2. Right around now, I would quickly do a double check. I would kind of reread what I've written. Yep, that looks good. Perpendicular of cos it is. 2 lines is sine. I would check for g's. Mr. Dewick, don't the g's cancel? There's a g in everything. Is there? Is there a g in the a over here? They don't cancel. But now it's time to plug in the numbers. You'll have to help me. I've scrolled down. How big was M1? Was it 5? Times 9.8 minus 0.05 times 8. I'm going from memory. Let me know if I'm wrong. Cos. Was theta 30? Yep. Minus, okay, double check. Mu m2g cos m2g sine all over 5 plus 8. Whew. Cos. Sine. I got 0.492706. Barely accelerating. It is, not by much. By the way, if you got exactly 0, that would tell you, oh, this system is not accelerating. It's either at rest or moving at a constant speed, but it's not accelerating. Is that right? Y'all got 0.4927 blah, blah, blah. So I'm going to write 0.493 meters per second squared, but you know I'm keeping this on my calculator because what's B want me to find? I think this time it's very obvious. Which mass would you prefer to use to find tension? Definitely M1. Yes? Because M2's got a bunch of junk on there. M1, which way is M1 accelerating? So which is winning in M1? M1G minus tension equals M1A. Gesundheit. Swappy dance. M1G minus M1A, that equals tension. 5 times 9.8 minus 5 times 0.493. You know I'm going to use my answer button there. Looking for typos. I think I'm right. You get 46.536, 46.5? So pretty much everything that we've done so far, I think, is fair game with ramps. The only thing I won't do on a test, I won't do a missing mass question with the ramp. In your homework, I'd be okay with that. Remember we did the Atwood machine missing mass question? I won't do one with a ramp on a test. In a homework, yeah, maybe even on a quiz is a nasty, but it's just overkill. Here's an example of a missing mass question. Did I go too far? Too fast? If you look at example 4 is an example of a missing mass question with a ramp. Tougher than I would ask on a test. Do you notice what are they asking me to find in part B? But first, what are they asking me to find in part A? And they had to give me either the acceleration or the tension, otherwise this is not solvable. In this case, they gave me the acceleration. Or I could have given you the tension, Karn, in which case part A would have said, find the acceleration. Okay. Free body diagram. Is this the last one, Mr. Duke? I think it is. Yeah, okay. M1G, tension. Theta's there. M2G, pause, components. Color, 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 color. Color, 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 color. Normal force number 2. That's way too big, I think, Mr. Duke. There, there. About like that. Tension. How do you know friction is up the ramp? Oh, that's why I had to tell you the direction of the acceleration as well. I had to. So it's accelerating upwards. M1 is accelerating upwards, so M2 is accelerating downwards. So friction force number 2 must be up the ramp. Find the tension. I don't know mass 2, so there's no way I'd use mass 2. So what's my equation for mass 1? Which way is mass 1 accelerating? Which way is mass 1 accelerating? Upwards. So revise your guess. Yep. Yeah. So tension is going to be M1A plus M1G. It's going to be 8 times 2.1 plus 8 times 9.8. And I won't round this at all, Marcus. I'll keep every decimal that I can because I'm going to be using this to find an answer. You get 95.2 even? Okay. All right. Whew. Now we're going to write an equation for M2. Okay. Who's winning? M2 is not a force. That's a mass. Don't tell me a mass is winning in a force equation. Which force in my free body diagram is winning? M2G parallel. I see some yawns. Instead of M2G parallel, if I wanted to skip a step in my homework, not on a test, what could I write instead for 2 lines? Boy, there was so much hesitation there. Maybe I shouldn't have allowed you to take that shortcut, but okay. So I'm going to write M2G sine theta. Keep going. We're writing an equation for mass 2. Look at your free body diagram. You've just decided that M2G parallel is winning. Nick, loud and proud. Equals M2A. Yes? Do you see what I meant by I'm not sure these are tougher, they're longer? Karn, friction. Which normal force? M2G perpendicular. Which trig function? Of course it is. So you ready? We're going to have this. M2G sine theta minus tension minus mu M2G cos theta equals M2A. Is that all right? It's complicated, but hopefully nothing new there. What was B asking me to find? How many M2s do I have in this equation? 3. How many would I prefer? Let's get them all to the same side. I'm going to swappy dance. I'm going to plus the tension over and minus the M2A over. That's going to give me M2G sine theta minus mu M2G cos theta minus M2A equals tension. How many M2s do I have? How many would I prefer? It'd be really cool. It would be really cool if there was a grade 9 mathematical operation that I could pull out of my back pocket and change this from 3 M2s into 1. There is! Yeah. I'll pull out an M2 and I'll get G sine theta minus mu G cos theta minus A. That equals tension. What am I trying to get by itself? Oh, what's the bracket doing to the M2? So I'll move the bracket over. Ha! Look at that. Wow. That's not bad. M2 is going to be tension divided by G sine theta, mu minus mu G cos theta, minus A. I have no idea what the answer is here. I don't even remember what tension was. 95.2 all over 9.8. I don't remember what thetas are. 28 degrees and 0.12. Sine 28 minus 0.12 times 9.8 cos 28 minus, I forgot what A was, 2.1. How will I know if I made a mistake? If you get a negative mass, because mass can't be negative. That's not antimatter. You made a mistake. (95.2) divided by a bracket. 9.8 times sine 28 minus 0.12 times 9.8 cos 28 minus 2.1. Close off the bottom. Ooh, typo, Mr. Dewick. 95.2. Dope. $95.2. Oh, not times, Mr. Dewick. Divided by, insert bracket. There, that's what you lost. You get 65.1? Yeah. Kilos. What's your homework? One, C and D You'll have to do A and B anyways, but I generally don't find friction separately. I do it in the equation. So find the acceleration, find the tension. You'll have to figure out by comparing the tug of war which way it's sliding. Is the 10 sliding down or is the 10 sliding up? 2 is a nice thought puzzle. Boy. 3, that's a chunk. I'm going to skip 3. Four is good. So it's at rest, but if pushed slightly, it'll start to slide. In other words, it's not accelerating. It almost wants to. It's just ready to go. Find which way it's going to move, and then figure out how big the friction force has to be, and find mu. If it's not moving, what's A? There you go. 5 is cool, but I'm going to skip it. 6 is cool, but I'm going to skip it. 7 is good. You want to dulp. 8 is good. You know what? 8, just do B. You don't have an 8? Generally comes after 7, sometimes before 9. You can skip a bunch. 12 is good. 13 is good. Before I turn you completely loose, though, first of all, let me pause the video.